All right, I'm going to show balancing half reactions. So some half reactions you can get straight from your data booklet, but some half reactions are not considered there. So you do need to learn how to balance them. There's 3 types of reactions that we're going to learn to balance. We're going to balance half reactions in an acidic solution. This is on your diploma. Balance half reactions in a basic solution. This is not on your diploma, but I will have it in a quiz in class. And you must balance disproportionation reactions. So a disproportionation reaction is something I will define a little bit later. It's just a really long word at this point. Okay, so there are a ton of steps here. I'm going to let you read through them, and what I'll do is I will simply go through each step individually through the example. Okay, so first thing we're going to do is balance in an acidic solution. So if we are asked to balance this equation here, we know that there's acid available, meaning there's H3O pluses available, and we also know that they're probably all aqueous because they're ions. All right, so there's also water. First step in our balancing is to split the reaction into half reactions. Now you don't need to know who is an oxidation and who is a reduction at this point. You simply need to split them based on elements. So NO2 minus is going to be one of our half reaction reactants, and MnO4 minus will be the second one. Now, NO2 minus cannot make Mn2 plus. It's impossible. That's not a conservation of elements or mass. So what we're going to do is it's going to make NO3 minus, and MnO4 will make Mn2 plus. All right, so I've copied down my reaction from our last page, and you don't need to write this down, but what I would do is in this example, write down each step individually, and then when we get better at it, we'll do it in one giant step. Okay? So next step, step 2, balance for atoms other than oxygen and hydrogen. Well, in my initial equation here, I have 1 nitrogen on this side, and I also have 1 nitrogen on the product side. So it's balanced, just not for oxygen. That's okay. Same thing for MnO4 minus. It makes 1 Mn2 plus. So atoms other than oxygen and hydrogen are also balanced here. So check, check. Next step, this is where we're going to get into some interesting balancing techniques that you guys have never seen before. In our first half reaction, we have NO2 minus making NO3 minus. Now in the reactant side, there's 2 oxygens, and on the product side, there's 3 oxygens. So I need to add oxygens. The source of oxygen in a redox reaction in aqueous solution is water. Water contains 1 oxygen. Therefore, now if we're counting just oxygens, I've got 3 oxygens on this side and 3 oxygens on this side. So we're balanced for oxygens and atoms other than oxygen and hydrogen. Second reaction, we have MnO4 minus making Mn2 plus. In the reactant side, I have 4 oxygens. In the product side, I have no oxygens. So I need to add water. To get 4 oxygens, I need to add 4 waters. Now, if we check oxygens, I've got 4 oxygens on this side and 4 oxygens from water on the product side. We are balanced for oxygens. Step 4, again, I've just copied this out from last time here, so don't copy that down again. We're going to add to it. So, balance for hydrogen atoms by adding H+. In my first reaction here, I have 2 hydrogens in the reactants from this 1 water. There are no hydrogens in the products, therefore I need to add hydrogens. Now the fact that this is in an acidic solution, that's where the H pluses are coming from. So I'm going to steal 2 hydrogens from the acid and add them into my reaction. Okay, same thing for my second reaction. MnO4 minus makes Mn2 plus and 4 waters. With 4 waters, we actually have 8 hydrogens. So we're going to add 8 H plus to the reactant side. Now we are balanced for all atoms, hydrogens, oxygens, and everything else in the reaction. The only thing we're not balanced for is charge. Next step. So we're going to balance for charge by adding electrons to the more positive side. We started with our H2O and NO2 minus. We're making NO3 minus and 2H plus. The total charge for all of my reactants here is -1. Water is neutral and we have 1 nitrite ion. On the other side, in our products, we have a 1 minus and 2 positives. Don't forget the coefficient will affect it. With that, we have a positive 1 charge in our products. To make these equal, what we need to do is add electrons. So we can add 2 electrons to our products, which will now bring our charge down to -1. They are equal. Same thing for our our second reaction. We have 8H plus and MnO4 minus, making Mn2 plus and 4 waters. Now, on my reactants side, I have 8 positives and 1 negative, brings me to +7. In my products, I have, I forgot the O. I have 2 positives. So I need to add 5 electrons to this side to bring our charges to be the same. At this point, that's when I can identify who is oxidized and who is reduced. So we are losing electrons in our first reaction, therefore this is our oxidation. Our second reaction is gaining electrons, this is our reduction. Now, just like in our other balancing, we need to make these number of electrons the same. To do that, what we're going to do is we are going to multiply our reactions. So we need to multiply this reaction by 5 to get 10 electrons and our second equation by 2. I'm going to write this out because if I've changed both coefficients, I just can't keep track of it in my head. So I'm going to get 5H2O and 5NO2 minus makes 5NO3 minus 10H plus and 10 electrons. Second equation should be 10 electrons. Look at that. They're both the same. Great news. H plus and 2 MnO4 minus makes 2 Mn2 plus and 8 waters. Last step is to add them up. So, like Hess's law, what we're going to do is we're going to cancel things that occur on opposite sides of our reactions before we add them. It's just going to reduce the amount of writing and rewriting our equation that we're going to have to do. So first thing you always want to check is electrons, because if the electrons aren't the same, you can't actually start canceling. So 10 electrons on opposite sides of the reaction, both cancel. We can reduce the number of waters. Okay, so there's 5 in a reactant and 8 in a product, meaning that we could only just make 3. That's okay. 10H plus, reduce this to 6. If we've added that up, that brings us to 5NO2 minus plus 6H plus 2 MnO4 minus. We'll make 5NO3 minus and 3H plus, 3H2O, and I missed 2 Mn2 plus. This is our total redox reaction. Once again, we can check our atoms. We have 5 nitrogens, 5 nitrogens, 6 hydrogens, 6 hydrogens. 5 times 2 oxygens is 10, plus 8 is 18. On this side, I have 5 times 3 is 15, plus 3 is 18. Great news, 2 Mn, 2 Mn. Checking charge. I have -5 and +6, which gives me +1. And subtract 2. Overall, we have a -1 charge on this side. On our other side, on our products, we have 5 times -1 is -5, plus 2 times +2 is +4, altogether bringing us to -1. Check, check, atoms and charge. Okay, so now I want you to try this one on your own. So pause the video and try it. What I'm going to do is go through my solution. So come back to it after you've finished. We split our reactions. Cl2 makes Cl minus. S2O3 2 minus makes SO4 2 minus. So first step is to balance for atoms other than hydrogen and oxygen. So we need 2 chlorines on our product side, because we have Cl2 to begin with. We have S2 as a reactant, therefore we need 2 SO4 2 minuses. Now what I was saying earlier is we've written out each step individually as you've gone. What you can do is you can do it only in 2 reactions and add them up at the end. So that's what I'm going to do here. I'm just going to keep adding as we go. So next step is to balance for atoms other than oxygen. For oxygen. There is no oxygen in our first reaction, so we're not concerned about that. We're just going to skip that step for it. In our second reaction, though, we have 3 oxygens on this side, and don't forget about the 2, we have 8 oxygens on this side. So that means I need to add 5 waters. All right. Now, again, in our first reaction, hydrogen's up next to balance. There's no hydrogens, so we're not concerned about it. Moving to our second reaction, there are 10 hydrogens on our reactant side and no hydrogens on our product side. So I'm going to add 10 hydrogens. All right, now we're at the point where we're going to balance for charge. So back to our first equation, we can balance for charge now. Overall charge is 0 on this side, it's all neutral, no charges, and -2 on this side. So to balance for charge, I need to add 2 electrons. In my second reaction, on our reactant side, water is neutral, so it doesn't contribute to charge. We get a -2. In our products, we have 2 -2, so that's -4, and 10 positives. Altogether, that's going to make +6. So what we need to do here is we need to add 8 electrons to our products, and now that brings that charge down to -2. All right. Sixth step is to multiply by a coefficient to get the number of electrons to be the same. So I'm going to multiply my first reaction by 4 to get 8 electrons. All right, so 8 electrons. We have 4 Cl2s and 8 Cl minuses. Total that all up. There's only one thing that can cancel, and that is our electrons. So we're going to get 4 Cl2s, 5 H2Os, S2O3 2 minus makes 8 Cl minus, 2 SO4 2 minus, and 10 H plus. That's our total redox reaction. You can double check for atoms and charges, but I'm fairly confident in my answer there. All right, balancing and basic solution. They are extremely similar. This process is extremely similar to acidic solution. There's just a couple of extra steps that I'll outline as we go. So we're going to do our first thing here, and that's split our reactions. And in case you haven't noticed, I've always dropped states because A, it takes up more room, and I can assume that all of these are their natural state. So this, of course, would be aqueous. This is going to be a solid. This is, a solid as well. Okay, we're going to assume that. You can add your states back in at the end, but we'll drop them throughout. Okay, balancing for atoms other than hydrogen and oxygen. So with I minus making I2, I need to add 2 I minuses here. For MnO4 minus making MnO2, we're all good. Next step, balance for oxygen by adding water. We don't need to add hydrogens or oxygens to our first equation. There are none in there, so don't worry about it. We're just going to continue balancing our second reaction. So there are 4 oxygens on this side and 2 on this side. That means I need to add 2 waters to my products. Don't drop your charges, whatever you do, or you're going to get the wrong answer for electrons. So 2 H2Os. Balance for hydrogen by adding H+. Well, like I said, we're not really concerned about our first reaction there, so I'm only going to keep writing out our second one. So MnO4 minus makes MnO2 and 2 waters. In our products, we have 4 hydrogens. Therefore, we need to add 4 hydrogens over here. Now, we know that we're actually in basic conditions. What we've done at this point is we've balanced all of the atoms using just hydrogen because it's simpler. But because we're in a base, what we're going to do is we're going to neutralize the acid molecules by adding the same number of hydroxides to both sides. The both sides is important because we've balanced our atoms already. You don't want to wreck what you've already worked so hard for. So we're going to add 4 hydroxides to both sides of our equation. All right, so MnO2 and 2 waters, and again, 4 hydroxides. Now, they don't cancel because before they get a chance to cancel, voila, we're going to combine an OH and an H plus because we know that those were going to make water. So 1 OH and 1 H plus will make 1 water. So overall, I have 4 waters. Now, you can cancel within an equation now if you would like, or you can carry your water molecules on. Your call. We can cancel 2 with the 2 waters there. Just for simplicity, because we're working so hard and there's so much new stuff happening, I'm going to keep all of them here. So it makes MnO2 and 2 waters and 4 OHs. All right, at this point, now we're going to add electrons. So revisiting our first equation, we have 2I minus, making I2. Total charge over here is -2. Total charge in our products is neutral. So we need to add 2 electrons. Now, in our second reaction, we have 2 H2Os and MnO4 minus. That makes an overall -1 charge in our reactants, making MnO2. Oh, it looks like I did cancel my water. Sorry, guys. And 4 OH minus. Go back and you can cancel if need be there. Okay, or just continue along. The same number of electrons will be present in my equation as yours because water molecules are neutral. Overall, in our products, we have a -4 charge, meaning that I need to add 3 electrons here. All right. Okay, so now all we need to do is multiply by 3 on this guy and by 2 here. And so we'll get 6I minus, making 3I2 and 6 electrons. On our second reaction, we're going to get 6 electrons, 4, my bad, good math, 4 waters, 2 MnO4 minus, making 2, best writing ever, 2 MnO2s and 8 OH minus. Okay, so you know the drill. What we're going to do is we're going to add these 2 reactions and simplify. But by simplify after, I mean before. Let's cancel our electrons first to make sure that we're actually ready to add our equations. Good thing, they're on opposite sides and they have the same number. Add them up. So 6I minus and 4 waters and 2 MnO4 minus makes 2 MnO2s, 8 OH minus, and 3 I2s. That's it. So attempt this one on your own here, guys. Pause it, and I'm going to solve it for you here. Okay, split up your reactions. CrOH3 makes, obviously, CrO4 2 minus, and ClO3 minus makes Cl minus. Balancing for atoms other than oxygen and hydrogen. Well, checkity check, they're balanced. Next is oxygens. On this side, we have 3 oxygens, and on this side, we have 4 oxygens, meaning I need to add a water on this side and 3 waters over here. To balance for hydrogens, take note, we have 3 here already, plus 2 is 5. And for our second reaction, we're going to add 6 H's down here, adding the same number of OHs to both sides. Plus 5 OH minus, plus 5 OH minus. Now these cancel, and we're going to get 5 waters. And these cancel, and we're going to get 6 waters. We can reduce that to a 3 and cancel. We can reduce this to a 4 and cancel. Okay, so now we just need to balance for charge. What I'm looking at in the reactants over here is a 5 minus overall. And in our products, it looks like just a 2 minus. Therefore, we need to add 3 electrons to the product side. In our reactants over here, looks like a -1. A -1 charge. And overall in our products, it looks like a -7 charge. So we need to add 6 electrons over here. So multiply by 2, add it up. I'm going to write everything out here except our electrons because we know that they're going to cancel. So I'm going to get 10 OH minus from the first reaction and 2 CrOH3. And from our second reaction, we have 3 H2O and ClO3 minus, making Cl minus, 6 OH minus. And from our first reaction, 2 CrO4, 2 minus, and 8 waters. So we need to cancel anything that's overlapped that looks like OHs. So we were going to reduce this one to 4. Waters, reduce that to 5. So overall we get 4 OH minus 2 CrOH3, ClO3 minus, making Cl minus, 2 CrO4, 2 minus, and 5 H2O. Hopefully everything's balanced. All right, disproportionation reactions. In this type of reaction, the same species is both oxidized and reduced, so it both gains and loses. This is referred to as self-oxidation reduction or autooxidation. This type of reaction occurs when a substance can act as both an oxidizing agent and a reducing agent. So Pb2 plus exists on both sides of our data booklet table. So in this case, Pb has lost electrons. So if it's losing electrons, it's oxidized, and it's also gained, so it is reduced. Same thing here. Later on, we're going to talk about oxidation numbers, and we're going to look that oxygen has both been oxidized and reduced. So we come back to this with oxidation numbers. Okay, balancing these is really no different. So what the only difference is that on the reactant side, we only have one iodine. So what we're going to do to split it into half reactions is go I2 to I minus, and then I2 to IO3 minus, and balance from there. So a 2, and 2 electrons in this one. We're going to add 6 H2Os over here. We're in an acidified solution, so I'm going to add 12 H plus over there. Total charge in our reactants is 0. Total charge in our products is positive 10. So I'm going to add 10 electrons. Multiply by 5 and add it up. So our electrons immediately cancel. We're going to have 5 I2s and 10 I minuses. So when we add it up, we get 6 H2Os and we get 6 I2s because we had 5 from our first reaction and 1 from our second reaction, and they're both reactants. We're going to make 10 I minus and 2 IO3 minus and 12 H plus. Now all of these could be reduced by 2. So you can reduce to 3 H2O, 3 I2, 5 I minus, IO3 minus, and 6 H plus. All right, so your homework is the balancing portion of your work booklet.